Hello everyone! Welcome to the Zoyer channel. Today we're going to reveal the invisible core component inside a laser cutting machine, the guide rail, that determines the machine's overall precision. The core functions of guide rails in laser cutting machines are guiding and load bearing, while minimizing frictional resistance. Modern laser cutting machines are equipped with rolling linear guide rails. Steel balls circulate between the rail and slider, converting sliding friction into rolling friction. Friction is greatly reduced, delivering smooth operation with nearly zero resistance. Many people wonder if the equipment load is fully supported by steel balls. The answer is yes, the load is entirely borne by precision steel balls. High-hardness steel balls inside the slider are evenly arranged to share the force. It achieves heavy load capacity with ultra-low wear for stable and smooth movement. The slider has a built-in ball circulation channel. Steel balls roll along the rail groove and return via the end reverser, enabling unlimited cyclic movement. The guide rail adopts a preload design to adjust internal clearance, eliminate gaps, and improve rigidity, ensuring no jitter or vibration at high speed. Two core parameters you need to know. Accuracy grade, H grade for precision and P grade for ultra precision, widely used in laser machines. Rated load, bearing combined vertical static load and horizontal dynamic load. 2. Importance of guide rails, the anchor of precision. As the core reference base for the overall machine movement, it directly determines the comprehensive performance and core value of the equipment. 1. Determines the overall operating accuracy. The straightness error of the guide rail is directly converted into dimensional deviation of workpiece processing. Meanwhile, the fitting clearance and structural rigidity of the guide rail directly affect the repetitive positioning accuracy of the equipment. Control the precision of the mechanical return to the origin every time, and firmly guarantee the consistency and yield rate of mass production. 2. Determines operating speed and working efficiency. Low-friction precision guide rails support sliding tables, manipulators, and moving modules to achieve high speed and stable reciprocating motion, greatly improving the overall working efficiency of the machine. 3. Determines the overall service life of equipment. High-quality precision guide rails can serve for tens of thousands of hours, with little wear or deformation during long-term operation. In contrast, inferior guide rails often suffer wear, looseness, and jamming failures after only a few thousand hours. 4. Determines later operation and maintenance costs. High-precision branded guide rails feature stable performance and slow performance attenuation, with simple maintenance and long replacement cycles, saving worry and cost in the long run. Inferior guide rails lose accuracy rapidly and have frequent failures. They require frequent calibration and debugging, and also cause wear on surrounding transmission parts with high scrap rates. Although they seem cost-effective at the beginning, they actually bring higher overall long-term costs. Whether it is CNC machine tools, automated manipulators, conveying assembly lines, packaging equipment, automated warehouse systems, or various intelligent transmission equipment, guide rails are the hidden core foundation. Choosing the right guide rail is the key to equipment operation with high precision, high stability, long service life, and low overall cost. 3. The relationship between guide rail and rack, synergy of the perfect pair. In the transmission system of a laser cutting machine, the guide rail provides guidance while the gear rack delivers drive power. The two form an inseparable perfect combination. Clear division of roles. Guide rail, like a railway track, it restricts the laser head to linear motion and provides guidance and support. Gear rack, similar to a gear belt, it meshes with the pinion driven by the servo motor, converting rotary motion into linear motion and providing driving force. The guide rail limits the moving direction, ensuring the rack's driving force is efficiently converted into linear motion and avoiding deviation and vibration. Their accuracy levels must be matched. The guide rail is usually one accuracy grade higher than the rack to guarantee overall motion precision. Key matching parameters. Parallelism. The parallelism error between the guide rail and the rack must be controlled within 0.02 mm per meter. Otherwise, poor rack and pinion meshing will occur, causing noise and abnormal wear. Preload. Guide rail preloading and rack and pinion backlash elimination designs such as dual pinion anti-backlash structure jointly ensure high rigidity and zero clearance during movement. Mounting reference. Both must be installed on the same rigid reference surface to prevent mounting base deformation from affecting fitting accuracy. 4. Global guide rail brand ranking. Who is the industry benchmark? The global linear guide rail market is highly competitive. Here is the ranking of mainstream international brands for 2026. THK, Pan, the inventor of rolling guide rails, featuring high precision and long service life, standard configuration for high-end laser cutting machines, relatively high price. Haiwen, Taiwan, China, cost-effective with complete product series, mainstream choice for mid to high-end laser cutting machines. Nieberger, Switzerland, ultra-precision and strong adaptability to extreme environments, applied to ultra-high precision laser cutting machines. Nesk, Japan, outstanding mute performance and high-speed capability, suitable for high-speed laser cutting equipment. Vuelix, Sweden, strong heavy load capacity and innovative design, ideal for heavy-duty laser cutting machines. Xico, Japan, leading technology in needle roller guide rails, perfect for compact laser machines. 5. History of guide rail development, evolution from wooden rollers to nanometer precision. The evolution of guide rails is a history of humanity's pursuit of low friction and high precision. Early prototypes, BC 18th century. Wooden raceways were used in the construction of the ancient Egyptian pyramids, reducing friction by rolling wooden rods. Wooden ball bearings were adopted on ancient Roman ships to support rotating tabletops. Early Industrial Revolution, 19th century. Dovetail guide rails. With an inverted dovetail cross-section, they relied on sliding friction for guidance, featuring low precision and fast wear. Linear plane bearings, an improved version of sliding guide rails that reduces friction by forming a lubricating oil film. Birth of modern guide rails, 20th century. 1944, the United States developed ball linear bushings, realizing unlimited linear motion. 1972, THK became the world's first company to commercially produce LM rolling guide rails, marking the beginning of the modern rolling guide rail era. 1,980 seconds, Taiwanese brands such as Haiwen and PMI rose rapidly, promoting the popularization of guide rails and lowering overall costs. Contemporary development, 21st century. Precision upgrading, from the micron level to the nanometer level for some high-end products. Material innovation, special materials such as stainless steel and ceramics are adopted to improve wear resistance and corrosion resistance. Intelligent technology, built-in sensors monitor guide rail wear and precision changes in real time. Eco-friendly design, maintenance-free lubrication technology is applied to reduce grease consumption and environmental pollution. 6. Guide rail maintenance, the key to service life extension. Even the best guide rails require proper maintenance. Below are the key maintenance tips for laser cutting machine guide rails. Daily cleaning. Frequency, once a week is recommended. Method, wipe the rail surface with dust-free paper or a soft cloth to remove metal dust and oil stains. Avoid blowing directly with compressed air, as it will force dust into the interior of the slider. Regular lubrication. Frequency, once a month, adjust according to actual operating intensity. Method, use dedicated guide rail oil or grease. Inject it into the slider through the grease nipple to fully lubricate the balls or rollers. Note, do not use grease with solid additives to prevent blockage of the circulation channels. Sealing and protection. Check whether the accordion protective cover is intact and replace damaged covers in a timely manner. Make sure the seals and dust rings of the rail slider work properly to prevent dust from entering the internal structure. Precision inspection. Check the straightness and parallelism of the guide rails once a month and adjust immediately if any deviation is found. Pay attention to abnormal noise or stuttering during movement, which may be signs of rail wear or internal contamination. Closing summary. All right, today we've taken a comprehensive look into the secrets of industrial guide rails. From working principles and classification to its importance and matching relationship with gear racks. From international brand rankings and development history, all the way to daily maintenance. I believe you now have a brand new understanding of this invisible guardian. Remember, guide rails are the foundation of laser cutting machine precision. Only by choosing high-quality guide rails, performing professional installation and proper maintenance, can your equipment deliver optimal performance and produce perfect finished products. If you find this video helpful, feel free to like, follow, and share. Zoryar, your reliable partner.